Mistake proofing in food manufacturing. Human error is an inevitable part of any system that involves people. Regardless of how stringent the regulations, how well maintained the machinery, or how highly trained the workers, something will go wrong at some point. When this happens in food manufacturing, food safety outcomes can be affected and the consequences can be catastrophic. So how do we mistake-proof our food manufacturing systems to minimise errors? Mistake proofing, or poka yoke, a Japanese word meaning error proofing, is a trusted method for reducing or eliminating errors. Since its inception, it's come to be a popular method for error detection and correction across numerous industries, including the electrical appliance and automotive industries. We shouldn't confuse poka yoke with other error-proofing techniques, however. Six Sigma, for example, employs a broader methodology seeking to reduce defects and variability in processes using statistical tools. Meanwhile, HACCP focuses only on food safety by identifying and controlling potential hazards that could harm consumers. Unlike other error detection systems, mistake proofing in food manufacturing aims to identify and eliminate the potential sources of errors and mistakes. Rather than trying to detect every single error that occurs, it works back up the food manufacturing system to find how and why errors occur. Once identified, the system can be altered to prevent the errors. Where can mistake proofing be used in food systems? It works best when applied to the following situations. Manufacturing steps that rely heavily on the worker's attention, skill, or experience, such as in the hand finishing of patisserie or bakery items. Processes where errors will impact the safety or quality of the product, such as critical control point monitoring tasks. Situations where there is a high worker turnover, necessitating constant training, or a high proportion of inexperienced workers, such as in a seasonal fruit packing house. Steps where products or processes are transferred between workers, such as work in progress picked up, or WIP that is, picked up by the next shift. Processing or production steps where a minor error could easily lead to a major problem later in the process, such as the weighing of critical ingredients like dough-raising agents. Situations where the consequences of an error would be expensive, dangerous, or insurmountable, such as a task where water overspray could contact a large container of liquid chocolate. Processing steps where errors or failures occur frequently, such as a manual carton filling operation with multiple products put in one carton in a certain pattern. How to develop a mistake-proofing system. A mistake-proofing system is designed to make it impossible, or at least very difficult, for mistakes to occur. Here's how to develop one. Step 1. Review existing procedures. Analyze production flowcharts, standard operating procedures, and other documents. Observe production systems in action and talk to floor personnel to identify areas of weakness. Step 2. Identify and prioritize errors. Evaluate each step in the food manufacturing process to identify potential human errors, both historical and theoretical. Use tools like failure mode effects analysis, FMEA, to assign priorities. Step 3. Determine the root cause. Fundamental to mistake proofing is the identification of the underlying cause. Sometimes they may be single point errors, such as a mistake in the written SOP, or a mistake repeated by just one person. However, be vigilant for systems errors where multiple points of failure converge. Step 4. Develop solutions. Either eliminate the step, substitute it for another process that is less error-prone, modify the step to make the task easier to accomplish without mistakes, or enhance error detection systems at the step. Solutions should include controls and alerts. Controls include inspection processes such as multiple checks by different personnel, or automated sensor systems such as optical sensors. Alerts such as bells, buzzers, or lights inform operators when errors have occurred. They should be set up to require confirmations on human-machine interfaces to indicate that the process can continue. For example, if a metal detector detects metal, alarms are activated and the machine should stop. The best solutions result in the simplification and standardization of tasks, equipment, and processes because these make tasks easier for workers, reducing the chance of errors. So how does mistake proofing in food manufacturing work in practice? Here are three real-world examples. Color coding systems that prevent cross-contamination in food processing by using different colored tools and containers for allergen-containing ingredients. Automated monitoring systems, such as those that regulate critical conditions like temperature, pH, and humidity in real time. And RFID tracking, which uses radio frequency identification for detailed tracking of food products through the supply chain, which improves inventory management and enables quick response to recall. Fun fact, the term poka yoke was initially known as baka yoke, or idiot proofing. Considering this a little harsh, the term was changed. The phrase is derived from poka or yokeru, which means avoiding an unthinkably bad move, like metal or glass in your food. Like many of Japan's most ingenious concepts, it was developed by Shingeo Shingo in the 1960s to reduce human error in industrial processes. He noticed that factory workers would often forget to add a spring under one of the switch buttons in a product. He implemented a two-step process which guaranteed that workers would notice if they'd failed to add the spring. The concept of poka yoke was born. Perspectives from the food safety trenches. A contributor to an online food safety forum recently suggested that worker compliance in food safety critical SOPs should be built into HACCP systems. That's HACCP, which stands for Hazard Analysis Critical Control Point Systems. And they should be built in the same way we currently consider the likelihood of food safety hazards. Shouldn't we, they suggested, also consider the likelihood of a worker not performing tasks correctly when we do a hazard analysis? It's an interesting idea. A CCP-related task that isn't carried out correctly is a food safety disaster waiting to happen. As an example, in the forum contributors' workplace, a food safety critical task was allergen cleaning, and the risk of non-compliance was high. They said they preferred not to rely on training and checking people, deciding it was better to eliminate the opportunity for mistakes in allergen cleaning altogether, and they ultimately removed all allergens from their products and processes. That's mistake proofing in action. Takeaways for food professionals. Mistake proofing can help food manufacturers make food more efficiently with less waste by reducing errors that would otherwise lead to increased downtime and expensive reworking or destruction of food and ingredients. Here are three key takeaways. Mistake proofing works best when achieved by simplifying processes and standardizing equipment, making it easier for frontline workers to perform tasks correctly. Technologies like automated monitoring and RFID tracking can remove opportunities for human error, thereby enhancing accuracy and compliance. Regularly review processes to identify inefficiencies and errors, talking with workers to foster a culture of feedback and continuous improvement. And in the email and the post, I've included 4 links to further reading, including reading about lean factories, learning about Lean Sigma, and a complete guide to poka yoke.